Alright, in this video, we're going to take a look at the case 2 of the linear search algorithm, the case where multiple occurrences of the elements occur, right? Now, take for example this array, which consists of the elements 3, 7, -1, 9, and 3. And the element that we are required to find is 3. Now, 3 occurs at multiple places. It occurs at the 0th index first, and then it occurs at the 4th index. Now, our algorithm should be able to display all the positions at which a key element occurs. Let's see how this would work out. Now, if you notice, in our dry run, we do not have the pause variable because in this particular algorithm, we are not going to find a single position, but we're going to find multiple positions. And we're going to display the positions as we find them, right? So just like before, our checking would start from the first element, right? Let's use the same color. On the first element is 3. Now, is our key equal to the current element? Yes, it is. That's true. Let's shift this a little. Let's get rid of it. So way too much time. And our output would be 3 was found at position I. That's 0. We change the color. Okay. Now we're going to increment the value of I, and then we are going to move on to the next element. The next element is 7. Now our key element is not equal to the current element, and this is why we are not going to output anything, right? Now we will increment the value of I again. We're going to move on to the next element in the array, that's -1, and -1 is not equal to our key element, that's false. Therefore, we're not going to make any output. Now we're moving on to the next element, that's 9, and 9 is not equal to our key element, that's false, hence the output is none. Then we're going to move on to our last element, that's 3 again, and this is equal to the key. Therefore, we're going to output 3 was found at 4. Alright, that's it. That's our algorithm. Now, if the element does not exist, it wouldn't give anything as output. Alright, okay. So let's check our algorithm now. So ARR is our array of elements, just like before, and N is the size of the array, and key is the element to be searched. Notice that we do not have the pause value here. Alright, now we run our loop from 0 to n-1. Just as before, we check whether the key is equal to the current element. If it is, then we display that key was found at position I. Alright, now let's see this particular algorithm in terms of a code. Alright, so this is linear search case 2. Same as before, import java.util.scanner class linear search case 2. Now I'm not going to write the input and the display function all over again. I'm just going to copy them from the previous code that I wrote. So let's open this. I don't know why it's coming in this way. Okay, so I'm going to copy the input and the display functions. Paste. Now, number 3, search for all the locations where key is present using linear search. So because our algorithm is not searching for a single location, therefore we're going to have the return type as void. Linear search, and it's going to take in an array as well as the key. All right. So we're going to have n, which is the length of our array, and we're going to run a loop. Int I equal to 0, I is less than equal to n minus 1, I plus plus. Okay. All right. Now we will check if the key element is equal to our current element or the ith element of the array, and if it is, then what we're going to do is system dot out dot println system dot out dot println key plus was found at position plus I. Moreover, as I think, we must also display something if the element does not exist, right? So I'm going to change it a little. I'm going to change the program a little. Let's head on to the algorithm first. We must also display if the element has not been found, right? So let's introduce the pause variable. It seems really bad if the program does not give anything as output. So it's going to be initialized with -1. And what we're going to do is, after displaying this message, we're going to store the index at I. Now, after everything, what we are going to do is, we're going to check the value of pause. Now, if the key was not found, right, then this condition would never be true, right? And because this condition would never be true, pause would never be any index other than -1. Pause would remain -1, the value of pause. So if the value of pause remains -1 even after traversing the array, then we're going to display key was not found. I should have included it from beforehand, but no matter. But it's all right. Written it now. Let's change our program accordingly. So I'm going to introduce the variable pause, assign it the value of -1, and we're going to store I here. Now, if key does not exist in the array, then this block of code would never run, and the value of pause would continue to remain -1. And we're going to check for that. If the value of pause is -1, meaning the element was not found. System dot out dot println key plus was not found in the array. Now, our main method is going to be same as before. Public static void main string args. So let me just copy some of the code from here. Not some, actually all of it. Alright, so let me take you through the code once again. So we are creating an object of the scanner class, then we are creating an object of this class. Then we are asking for the size of the array. We are creating a new array. We're taking input in this array. Next, we are asking for the element that needs to be searched in the array. Now, we display the contents of the array here. Then we call the linear search function and pass it the array. We don't need this anymore. And pass it the array and the key. Now, inside of this function, it checks whether the key exists, and it prints all the occurrences of the key that exist in the array. Right? So I hope you have understood the changed algorithm, the version 2 of the linear search. Now, in your exam, you might be asked either of these. You might be asked to write a program that would display all the occurrences of an element, or you might be asked to display only the first occurrence, the index of the first occurrence of an element. Now, if it's the first case where you need to display all the occurrences of the elements, then this would be your linear search algorithm. But if you are asked to display only the first occurrence of the element, then this would be your linear search algorithm in that case. All right. So I hope you have understood the linear search algorithm, the version 2 of the linear search algorithm, and see you in the next one. Bye for now.